Welcome to MOVITRAC LTP-B Basic and Intermediate Training. This is Session 2. In this session, we're going to get our MOVITRAC LTP-B connected up, and then we're going to do a quick startup to get the motor turning. But before we do that, I want to give you an obligatory warning. Whenever you're working with a MOVITRAC LTP-B, you should always disconnect power and wait a minimum of 10 minutes before working with the electrical connections on the VFD. If you don't wait 10 minutes, you could get an electrical shock. That is because the VFD has capacitors that remain charged for a fairly long time. If you wait 10 minutes, then they will have discharged down to a safe level. So, you have been warned. So let's talk about getting our VFD connected up to power and to our motor. We'll start with power wiring. You should always connect power and ground according to the guidelines in the MOVITRAC LTP-B manual, as well as your local electrical codes. And of course, that includes details such as protective devices like circuit breakers or fuses. The IP20 models are pretty much the same, whether they're single-phase or three-phase. The only difference is the single-phase model has one less connection. On the single-phase model, the protective earth or ground connection is right here, and it's identified in green. And then there are two connections for the live and neutral. The three-phase model has the protective earth in the same location, and it has three terminals for the L1, L2, and L3 wires. That is all you have to connect to get your drive connected to power. Now, the IP55 and IP66 models are similar. All the connections are under the protective cover, so you'll need to remove that. I'm also going to mention that there are some differences among models depending upon their size and upon the year in which they were manufactured. This is just one example. You should find them all similar, but do be aware there may be some differences. Single-phase models will have just an L and an N connection, whereas three-phase will have L1, L2, and L3. The protective earth or ground connection is right here. And these terminals handle the three phases L1, L2, and L3, or just live and neutral for the single phase. A very important note before we talk about connecting up the motor, all MOVITRAC LTP-B models, even the single phase ones, drive three-phase motors only. So you cannot connect up a single phase motor to any of these models, even the ones that are single phase on the input side. So how do you wire up the motor? Again, relatively simple. And I'll just say this one more time, always connect the motor up according to the manual and your local electrical codes. On the IP20 models, the connections are down on the bottom. The protective earth terminal again is marked in green, and the three phases U, V, and W are down at the bottom as well. On the IP55 and IP66 models, everything is connected inside under the protective cover. Again, here's the protective earth terminal, and here are the UVW terminals. Pretty simple, pretty straightforward. I think it's time for a demonstration. I'm going to show you how to wire up an IP20 model. I'm going to use the one on my demo unit. I'll connect up the power and ground terminals on the top, and then I'll connect up the motor on the bottom. So here we go. All right, the first thing I'm going to do is connect power and ground. My wires have been terminated with ferrules since I have stranded wires. I just insert them into the connections above the screws, and then I tighten the screws down. Since this is a demo unit, I'm just tightening them snug, but in a real application, you should torque them with an appropriate torque tool to the value specified in the manual. All right, now we're going to connect the motor, ground, and phases. So again, we insert the ground connection and phases U, V, and W into the slots behind the screws and then tighten the screws down. And of course, these two should be torqued to the proper torque specified in the manual using an appropriate torque tool. That is everything. We're now wired up and ready to run. Now, there are a number of additional things that you might wire up depending upon your application. Let's talk about brake resistor wiring. Brake resistors normally are installed inside the VFD, and I refer you to the manual as to the way you put it in. It depends whether you're using an IP20, IP55, or IP66 model. However, the actual wires to the brake resistor go to the two terminals at the bottom of the VFD. These are often behind removable plastic plugs, as is shown here. You'll have to break these out, and then once they're broken out, you can insert the wires and tighten the screws. So connect them to the plus and BR terminals, and that is it. On an IP55 or IP66 model, these are inside, and they're sometimes behind a removable plastic cover, especially if you have newer models. So pop that cover off, insert the wires, and tighten them down. And again, the terminals are identified in the same way with a plus and BR symbol. Now, a little warning. When the VFD is operating, the brake resistor may have up to 900 volts across it, so be very careful. This can give you a very dangerous shock. You have been warned. Many motors include thermal protective devices, either thermostats or thermistors that monitor the temperature of the windings. If the motor gets too hot, these will signal the VFD that it needs to shut down so the motor can cool down and not destroy itself. There are a number of different styles available, and the MOVITRAC LTP-B can support all of these. Now, if your motor has a TH or TF temperature sensor, that is either a thermostat or a thermistor, that is certainly supported. But some motors may include the more advanced KTY84 or PT1000 sensors. These are advanced thermistors. It doesn't matter, they're all supported. Here's how you wire them up. You make the connection to the front I/O connector. If you have a TH or TF sensor, connect it between 24 volts and analog input 2, digital input 5. The sensor must have a 2.5K ohm threshold in order to be detected correctly. Now, if you have a KTY or a PT1000 sensor, it's wired in a different way. You connect it between 10 volts and analog input 2, digital input 5. There are also some parameters that have to be set up to monitor it. We'll talk about those in a later session. What if your motor has a brake? Is it possible to control it through the MOVITRAC LTP-B? And the answer again is most certainly. You'll need to use an external brake controller like the SEW Eurodrive BMK or BMV. You'll connect it up to relay 2, and the MOVITRAC LTP-B will be able to trigger the brake through that relay and the brake controller. So this is the relay terminal connection. We wire everything up as shown here. This is a diagram from the MOVITRAC LTP manual, and this is the relay right here. It should go to pins 17 and 18. So you wire the BMK or BMV to those two terminals, and that is it. We will talk about how you set up the VFD to control the brake in a later session. Now, a little warning. When you're using a motor brake with a hoist, a vertical, or an angled application, it is crucial that you always follow the guidelines in the MOVITRAC LTP-B manual to ensure that you have set everything up correctly. If you do not do this, you may have some unsafe brake behavior. So, read the manual carefully. It thoroughly explains how to set things up. Now, we need to talk about a safety feature that's built into the MOVITRAC LTP-B. It is called Safe Torque Off, often abbreviated STO. Safe Torque Off prevents the drive from developing torque. When you trigger the drive to go into Safe Torque Off mode, basically what happens is it goes into what we call controller inhibit mode. The output stage is disabled. The transistors that power the motor will not deliver energy to the motor, therefore it will not develop torque and it won't move. Safe Torque Off is a safety mode, so when you trigger it, it will enter this mode. There are two terminals on the I/O connector that enter or exit Safe Torque Off mode. They are labeled STO plus and STO minus. The VFD will not run unless STO plus is connected to 24 volts and STO minus is grounded. So if you want to use this feature with a safety circuit, you'll need to connect suitable control circuits to these inputs. This is outlined very thoroughly in the MOVITRAC LTP-B manual. Now, what if you don't need this feature? What do? If you don't need it, you can simply jumper STO plus to 24 volts and STO minus to ground, and the VFD will be permanently not in Safe Torque Off mode. Little warning here, you should follow the guidelines in the MOVITRAC LTP-B manual for wiring up a Safe Torque Off control circuit. If you wired up incorrectly, the VFD might not behave in the correct way, and that could compromise safety. So read carefully and do that wiring. Also, second warning, be aware that Safe Torque Off does not render the VFD electrically safe. This is not like a lockout tagout feature. The VFD is still powered and it could deliver a dangerous electrical shock. So safe torque off renders the drive mechanically safe. It keeps it from delivering torque by the motor. It does not render it electrically safe. Again, you have been warned. All right, well, everything is wired up. We're now ready to do a quick motor startup. I'm going to show you how to configure an asynchronous motor in VF mode, which is the simplest motor control mode. This is the mode that will work with virtually any asynchronous motor. It requires very little work to set up. It's very simple. So let's talk about it. To do this, we need to dive into what's called the parameter tree. Parameters control the VFD's behavior, or they report its condition. The parameter tree is the complete list of parameters. There are 283 parameters in the MOVITRAC LTP-B. That is a lot. However, to do a quick startup, you only have to work with what are called the basic parameters. These are 15 parameters in the Group 1 section of the parameter tree. We will talk about the parameter tree in much more detail in our next session. For this session, we're just going to worry about the 15 parameters shown here. And you don't even have to deal with 15 of them to do a quick startup. You only have to deal with about 7. So it's really very quick and very simple. And here's a little handy tip. The quick reference card lists the basic parameters on one side and the I/O connector signals on the other side. You can pull this out on an IP20 model and refer to it if you don't have a manual. On an IP55 or 66 model, it's behind the protective cover. Now, to set up parameters, you need to use the keypad. You're going to go into parameter edit mode and you'll set parameters using the keypad. Of course, it is possible to engineer the drive with a PC, but we won't cover that in this session. We'll cover that in a later one. Let's talk about what the different buttons do. The buttons all have multiple functions. It depends whether the VFD is stopped, running, or in parameter edit mode. So let's talk about the functions for each of these. The green button is the start button. It will run the drive, and when the drive is running, it will also reverse its direction. The red button is the stop button. It will halt a running drive, and if the VFD is faulted, you can use it to acknowledge and clear the error. The hexagon key serves 3 purposes. It's officially called the navigate button. When the VFD is running, it will select from different status display screens. It can also be used to enter parameter edit mode, and when you are in parameter edit mode, it functions like an enter button. The up arrow allows you to increase speed when the drive is running, and you use it to increase a parameter value when you're changing a parameter. The down arrow reduces the drive speed when it's running, and it's used to lower a parameter value when you are in parameter edit mode. The first step in a quick startup is to reset the VFD, sometimes referred to as factory defaulting it. What this does, it returns all the parameters to their default values. In order to reset your VFD, digital input 1 must either be turned off or it must be unconnected. This disables the VFD. You cannot factory default the VFD with it enabled because that is potentially dangerous. Then you must enter controller inhibit mode either by triggering safe torque off or leaving the 2 safe torque off terminals disconnected. So STO plus and STO minus must be disconnected, or your controller inhibit safe torque off circuit must be triggered. The way you will know you are in safe torque off mode, controller inhibit, the display will change to inhibit. So you want to see this on your display in order to factory reset it. Once that is true, then you move on and you do this. You press and hold these 3 buttons, the stop button, the up button, and the down button all at once. It is a little tricky. You have to do a little finger gymnastics there, and you need to hold them down for several seconds. What will eventually happen is the display will change to PDEF, which means that you have just factory defaulted your VFD. Then you must press the stop button to acknowledge the message, and you can go ahead and enter parameter edit mode and configure your VFD. Okay, it's time for another warning. After you factory default a VFD, it is very important that you do not remove controller inhibit or enable the VFD. STO plus must not equal 24 volts, STO minus must not equal ground, and digital input 1 must not be on. The reason you want to avoid this is because if you enable the VFD and you remove controller inhibit, it is possible for the motor to start running. What you want to do is wait until you've gone through the complete motor startup before doing this. So leave everything the way it is, proceed directly to the motor startup, and all will be well. Alright, so now we're ready to set the basic parameters that are required to complete a quick startup. In order to set these correctly, you'll need to take a look at your motor's nameplate and gather some basic information. So this is my motor's nameplate. You'll need to locate the motor's key electrical and mechanical parameters from it and fill out this little chart. You'll need to figure out what the motor voltage is. So on my motor, I have two possibilities since my motor can be wired either as double star or single star. In my case, my motor is wired as double star, so the voltage is 230 volts. If you're not sure how your motor's wired, you may have to look in the conduit box and check the wiring. Next, you'll have to figure out how much current your motor draws. My motor draws 1.84 amps when it's operating in 230 volt mode, so I write that down. Then I have to find my motor's frequency, which in my case is 60 Hertz, which is true of most motors in the United States. And finally, I need to find my motor's nominal speed at that frequency, which in my case is 1700 RPM. That is all I need to know in order to parameterize my drive and get it ready to go. So what we now need to do is enter parameter edit mode, and here's how you do it. You enter parameter edit mode by holding down the navigate button for 3 seconds, and the way you'll know you've entered parameter edit mode is you will see P1-01. What that is saying is you're ready to edit parameter 1-01. What you will do then is use the up-down arrows and the navigate button to select the parameter you wish to edit. So you move up and down through the parameter list. When you find the parameter you wish to edit, you hit the navigate button, which behaves like an enter key. You will then be able to set the value of the parameter using the up and down arrow buttons and the navigate key. When you've done that, you can move on to another parameter using the up and down arrows and navigate button, or if you're finished, you can exit parameter edit mode by holding down the navigate button for 3 seconds, and the display should return back to inhibit. So here's what we need to do a quick startup. We need to set the following parameters in this order. You set parameter 1-07 to the motor's voltage. In my case, it's 230 volts. You set parameter 1-08 to the motor's current in amperes. In my case, my motor draws 1.84 amps, so I key in 1.8. You have to key in the frequency to parameter 1-09. In my case, it's a 60 Hertz motor, so I set it to 60. Next, I have to set the motor's nominal speed. I set this in parameter 1-10. In my case, it's 1700 RPM. Finally, I have to set the control mode. In parameter 1-12, I set it to 2. Now, perhaps you're wondering, where did I get 2 from? Glad you asked. Here we go. The MOVITRAC LTP-B is extremely flexible. It has 9 different control modes, and here they are. Terminal control mode is controlled by switches and potentiometers. We sometimes call that binary mode. Modes 1 and 2 are keypad control modes, where the front keypad controls the VFD. Unipolar mode operates it in just one direction. Bipolar operates it in both. User PID mode is controlled by an analog signal. This is a fairly advanced control mode. Slave mode is controlled by another VFD, where another VFD sends commands to this VFD and it operates as a slave. And then finally, the last 4 modes are controlled by field bus devices. So in our case, we're going to pick mode 2, which is keypad mode bipolar. So that's where the 2 comes from. Now there are 2 additional parameters which you can set optionally. Parameter 1-01, this is the maximum speed you can run the VFD, and parameter 1-02, which is the minimum speed. Now by default, the VFD will set these to the 0 Hz and 60 Hz speed. Remember, speed depends not just on frequency, but on the number of poles in the motor. In my case, I have a 4-pole motor, so at 60 Hz, my motor will run at 1800 RPM. And of course, at 0 Hz, it will be turning at 0 RPM. Now, what are these parameters for? They allow you to limit the motor's maximum and minimum speeds. So if you set these, you can operate the motor in a more restricted speed range. You could, for example, say you don't wish to run it above a certain speed or below a certain speed. So set these parameters if you wish, otherwise just leave them at their default values. And that is all you have to do to parameterize the drive. So at this point, you would exit parameter edit mode and you would enable the drive so it's ready to run. Now for the drive to run, you need to do two things. You need to remove controller inhibit, and you need to turn digital input 1 on to enable the drive. So to remove controller inhibit, safe torque off plus and safe torque off minus must be connected to 24 volts and ground. And to enable the drive, digital input 1 must be connected to 24 volts. You can wire up switches to do this, or you can wire up jumpers. So this is how you would jumper it if you would wish to do it in that way. In my case, I have a little switchboard installed on mine. It looks like this. The two switches on the right are connected to the safe torque off positions. The three switches on the left are connected up to digital inputs 1, 2, and 3. So I would need to turn this switch on here, the one on the extreme left, which would turn DI1 on to enable the drive. So for my drive to run, these switches all need to be in the on position, which is down. The reason I'm mentioning this, you're going to see me doing this throughout the course, so I want you to know what these switches do and why I'm flipping them. All right, now once you've enabled the drive and you've removed controller inhibit, something is going to happen. The drive is going to want to auto-tune itself. When the drive auto-tunes itself, what it does is it's taking some measurements from the motor. It runs a small amount of electric current into the motor, it measures the electrical behavior, and it adjusts some parameters automatically. The first time you try to run the drive after a factory default, it is going to want to auto-tune itself. So here's what you need to do to auto-tune. And I'm going to preface this with a warning. The motor may move during auto-tuning, so confirm that everything is safe before you start the process. You don't want it moving the application in a way that could damage something or injure someone. So do be aware that when auto-tuning starts, the motor might move. All right, so what you've done is you've removed controller inhibit, you've enabled digital input 1, simply press the start button and that will start auto-tuning. And what will happen is the display will say Auto T. You'll hear some high-pitched noises coming from the motor, and in about 15 to 30 seconds it will go off and it will say stop. And at that point the drive is now ready to run. So to run the drive by the keypad, it's really very simple. It will be displaying stop if controller inhibit has been removed and it's enabled. Press the green button to start the motor. Press the up button and the down button to adjust the speed. Now when the drive is running, if you wish to change the direction, you can press the start button again, and that will cause the motor to reverse and go in the other direction, assuming you are in a bidirectional control mode. And what will happen is the VFD will slow down, stop, and reverse. So in this case, I go from running at 750 RPM clockwise to 750 RPM counterclockwise. And then, of course, to stop the drive, simply press the stop button and it will decelerate and come to a halt. Pretty simple. When the drive is running, you can have one of 4 different status reports on the display. Simply press the navigate button to cycle through your choices. The first one will display the frequency that the VFD is outputting. The second status panel will show how much current the motor is drawing. The third, how much power it's using in kilowatts. And the fourth, the speed in RPM. And when you press the navigate button on the last one, it cycles back to the first one. I think it's time for another demonstration. Let's go ahead and get our drive configured in quick startup mode, and then we'll go ahead and run it. We'll begin by factory resetting the VFD. Now, I've placed my VFD in controller inhibit. I've turned off DI1 to disable it, and I've turned off the 2 safe torque off switches as well. You can tell we're in controller inhibit because the display says inhibit. And now I'm going to press and hold stop and the up and down buttons. All right, you can see that my VFD is now displaying PDEF. I'm going to clear this message by pressing the stop button. Now I'm going to be very careful not to enable the drive or remove controller inhibit. I'm going to go straight into parameter edit mode to set up my drive. That way the motor will not run and we won't enter auto tuning at this point. So now we need to set the basic parameters. I'm going to enter parameter edit mode by holding down the navigate button for 3 seconds until it changes to parameter 1. There we go. Now we're going to go ahead and set our parameters. All right, I'm going to navigate to parameter P107 and hit the navigate button. That's motor voltage. I'm going to change this to 230 volts. There we go. Hit navigate to accept it. Move on to parameter 8. That's motor current. I'm going to change this to 1.8 amps and hit navigate. I'm going to go to parameter 9. That's frequency. We just keep this at 60. Parameter 10. This is the motor's nominal speed. I have to set this to 1700 RPM. You notice the longer you hold the button, the more it accelerates. It's kind of a trick to get the right number. I'll show you a better method in our next session. For now, though, we'll just get this up to 1700 RPM. And there we go. We hit navigate again. And now I go to parameter 12. That's the control mode. I set this to 2, which is keypad control bidirectional. Hit navigate. And then finally, I'm going to check parameter 1 and 2, which is the motor's maximum and minimum speed. I'll leave it at 1800 RPM. And I'll leave this one at 0, so we have full motor range. And we exit parameter edit mode by holding down navigate for a few seconds, and there we go. All right, finally, we are now ready to run the motor. Now, the first thing we have to do is run the auto-tune step, because that's the first thing that needs to happen before we can run the VFD. I'm going to turn the 2 safe torque off switches to the on position to remove control or inhibit. I'm now going to turn the digital input 1 switch on to enable the drive. You can see it now says stop. I'm going to press the start button, and that will enter auto-tuning automatically. Here we go. All right, you can see it's tuning itself. This will take about 15 seconds. All right, and that's over. It's displaying stop again. It means it's finished tuning, so now I'm ready to run the drive. I'm going to go ahead and press the start button. And now I'm going to change the speed using the up and down arrows. So I'm going to go ahead and ramp up. So there you can see we're now running at a constant speed. Let's reverse direction. I'm going to press the start button again to change direction. You notice we decelerate. And we're going to reaccelerate in the other direction. So that's counterclockwise rotation. Let's reverse direction here. We'll go back clockwise. Let's cycle through the status displays. You can see we're displaying hertz right now. I'm going to press the navigate button. Now it's displaying how much current the motor is drawing. Press it again, how much power the motor is using. Press it one more time. Now we have the speed in RPM. And you can see if I keep pressing navigate, it just keeps going around in a circle displaying the 4 status values. And now we'll come to a stop. And finally, I will disable my drive by turning digital input 1 to off. That I will leave my safe torque off switches on, so my drive is not inhibited, but it is disabled. And that's why it says stop. And that's it. Pretty simple. And that is the end of session 2. So, I hope you found that interesting and instructive, and you can see it is very simple to get a MOVITRAC LTP-B up and running. In our next session, we're going to learn about ramps, which control how the VFD accelerates and decelerates. We'll explore different ways the VFD can stop, and finally, we'll unlock what is called the extended parameter list. This will let us do a lot more things with our VFD. See you next time.